Welcome to the DESI ASTRO. In this Python tutorial on Astropy, our objective is to learn that how to visualize your astronomical data cube through the animation. So here animating data cube means in part 1 we will be visualizing the data cube 2D image at your each spectral axis or along Z axis. And then in the second part, we will visualize the data cube one-dimensional spectra at your each XY spectral. Okay, so these things we will be doing with Python coding and animation. Okay, so for that I will be using SDSS MANGA telescope. Okay, for getting a data cube from the IFU spectroscopy, okay, integral field spectroscopy. So here you can see that the simple data cube, okay. So you have like your X and Y axis and Z axis, your wavelength axis. So for every cut along your Z axis, it will give a galaxy image at a single wavelength, okay. And for your each XY spectral along your X and Y position, it gives a flux density and wavelength. So basically it's a spectra, right? So this is the image collapsed at all wavelengths, okay. So it's a white light image. So same thing we have to like visualize, like how to get your spectra like in a single frame with varying spectral, and how to get your all images at varying spectral axis, right? So let's do these things with animation. All right, so before starting we need to download this data, okay. So here's the link of the Marvin database, or you may just type here SDSS Marvin, okay, and click on that. So go to this website Marvin, click on that, and then click on this image, and then here you can see that you have plate or ID designation. So you don't know any ID, so for time being just type here 1 and see, it will automatically suggest so many MANGA ID and plate IFU. So just click for the second one, and so here you can see that plate IFU and MANGA ID of the object, right? And here you can see that this is the galaxy image. So it seems that it is a spiral galaxy, and this is the spectra, okay. So let's download the data cube. So for that, go to here, go to okay, so only 10 seconds is left in downloading. Okay, so our data cube has been downloaded and its size is around 140 MB. So let's go to the file section, and here is my data cube. So you can extract it, extract all. So here's my data cube. So copy it and put in my directory of the Python code, okay. So here's my data cube. Right. Now we will be reading this data cube, okay. So let me block this, right. So Now I will read this data cube using Astropy, okay, feeds file. So first import library, right? So from astropy.io import feeds, right? And then you can open your data cube. So just type here cube equal to feeds.open, right? And then type here MANGA. So this is your cube, right? 12514. Let me check it. Okay. So yeah, this was my data cube 12514. Now I am sure. So now this is my data cube, okay. So this will this command just open data cube, right? Then you can get some file information about the your data cube. So data cube information. So data cube information. For the type here cube dot info, and you can give the function. So here you can see that you have your flux and your wavelength, okay. So the second edge is flux and your the seventh one is your image edge, okay. So you have dimension of x, y and z, okay. So these are the spectral. This is your z axis. So this is your wavelength axis, right? So let's first extract, okay. So first extract image or 2D image at single spectral z axis, okay, right? So for that type here say called image equal to cube, right? And cube, and then give one for the flux, okay. So 1, and then give attribute dot data, okay. So dot data. So here you can see that to print it, to give some array, and you can check the shape. So check shape here. You can see this is your z, this is your y, and this is your x, okay. Now we have to plot it, okay. So plot 2D image, at a spectral z axis, okay. So for that type here plt dot image show, okay, IMSO, and then you can give image, okay. And now this is a data cube, so okay, it will have three index, okay. So just type here square bracket, and see your spectral axis have the length 4563, okay. So you can give anyone, say I want to open the image at 1000, okay, along the spectral axis, right? So and then give all spectral. This is like your z. So I just comment it here. So this is your image, this is your z, then this is like your all x, and like all y and all x spectral, right? Now run it. Okay, so not defined, PRT is not defined, so define your Matplotlib. So import matplotlib dot pyplot as PRT. Okay, and now can also import numpy if needed. So import numpy as np. Now run the code and wait. So here you can see that you have a galaxy image. Okay, and you can also give a color map. So cmap equal to jet, and you can give origin equal to lower to make this origin at 0 0, not 060, right? So you can give origin equal to lower, right? And also you can give a color map. So plt dot color bar. Make it 2000, okay, and here 2000. So image will look little bit different, okay, and then you can maximum go up to 4563. Okay, so it's out of range. So in Python it's take n-1. So your cube size is this one. So you have to give a 4562, right? So there's nothing, right? So I'll just put here 1000, and your image is at 1000 along z-axis index. Okay. So now what we have to do? We have to like obtain its all image, okay, along z-axis, and visualize that how it is looking at each your spectral axis. So let's do it. Let's extract all 2D images along a spectral axis. Okay, so spectral axis, right? So for that we'll be using for loop, right? So for I in range, okay, so for I in range, maybe you can give this number 4563, right? So 0 to 4563, right? And then you need to plot this image, okay? So for that, type here plt dot image show, right? And okay, then give your same this index, okay, image, right? So and for replace your this index equal to I, okay, and then you can also make this stuff color map, color bar, right? So yeah, then you can also give a title, and color bar. So image at z equal to a square bracket and dot format you can give I, okay, and then you can save this plot, okay. So plt dot save save figure, right? Then you can give a folder name, right? So you can give folder name equal to data cube image, okay? And then you can give the file name as a image underscore z, okay, z dot png, right? And so before, okay, so before saving this plot, we need to like create this folder, okay? So go to here and then create a new folder here. So give this folder name as a, okay, so new folder, and give this folder as a name, this name, okay, and then save it, okay, data cube image, okay. Now run this code, right? So run this code, you can see your code is running, right? What is the mistake here? Okay, so data cube image, I think there is no such directory here. Let me check. Okay, so you need to like also give here also type here plt dot figure for new figure for inch plot, okay, and then run this code, okay. So now my code is running for your all x-axis, right? And let's check it in the file. So our setup is done now. Okay, so this is like a very big number of images. So for that I will import a library here, maybe import above, so like tracking the time that how it is progressing the images time. So from tqdm import tqdm, right? So this is a library like used to like track the progress of your running the program. So for that type here tqdm and then give the bracket here. Now run the code, okay. So for your saving these images, or run it. You can see it is very slow, right? So it is going on. Maybe you can, okay, so 2% is completed. So I think it will take much time. Okay, so estimating time is around 15 minutes. Okay, so let's go and check it. More than 90% of the image saving is completed. Now it will take more or less 1 minute. $99. And here it completed 100%. Okay, so now your all figures has been completed. Now we'll be doing animation with these images. Okay, so let's do it. Okay, so till we have extracted all images of the galaxy along a spectral axis. So now what we will be doing, we will be animating these images at different spectral axis, okay, with ImageIO library. So let's do it. So first I will import glob library. So this is like used to read your all images from the your file, and then I will import ImageIO dot version 2 as ImageIO, right? So this is like used for your used to read all PNG files, okay, and this is used to make animation, okay. Now come here. Okay, so first like I will collect your all files. So collect all PNG files, okay. So for that I will type here, say images equal to glob dot glob, and then I can give my folder name, okay. So in my case the folder was document. So here I have saved my all 4563 images, okay. So here you can see that images are here. So you have to make animation out of these images, okay. So my file name is this one. So right, so just copy this, right, and then I'll go to my code. Now type here this, and then a star dot png, okay. So it will take your all png file from this folder, right. So you can print images, right, images 5 or 5. So here it comes, okay, right, or just 0. So 0.png or 1.png, right. So this way it will come, right. Now I will okay. So I will store this images frame by frame in a new variable, okay. So just make here say image file, okay, images file, right, and then I will read each image from file and store them in a list, okay. For doing that, type your variable called image, okay, and give as a empty array, and then append it, okay. So for that type here for j in range of image files, okay. So for j in image files, right, and then you can append it, okay, append in this image variable, right. Append in this image variable, right. So for that image dot append ImageIO dot im image read, and then you can give this index, right? So this will read each image from the and store in this image list. Okay, so you can check it. What is my image list? So image of 5, right? So I think it is still running. So maybe they are showing files, so it will take some time to run it. Okay, so yeah. So we need to wait, or maybe just you can know that how much time it will take. So go here and just okay, and then you can put here tqdm and then close it and then run it. So it will show that how much time it will take, okay, to run this file. So it will take around 1 minute, 2 minutes. Let's wait for that. So it will take around 30 seconds. All right. Right, so all five image files has been read and stored. Okay, so this is the array of the pixel value of this image. Right, now create animation out of this. So create animation and save into a GIF file. Okay, GIF format. So for doing that, type here ImageIO dot memsave, right? Memsave, and you can give your file name. So you can give my file name as a data cube image visualization, okay, dot GIF, okay, and then you can save your all images. So image, right? So image, write this variable, and then you can give a duration, okay, so like how much time you want between the frame, okay. So duration you can give say 5, okay, and then you can print here, say print my animation is ready, okay. Now run this code. So you can see it is still running. It is showing the asterisk sign in the square bracket. It means that your animation is still in process. So when it will be ready, it will print that it has been task has been completed. So let's wait. Okay, so here you can see the output that my animation is ready. So now go to my file, okay, and search for this file. So search here. So search for the file, this file. Okay, so it will almost complete it. Okay, so this is my final, okay, and it is again started from the zero. So this is the thing we have to visualize using data cube, right? So I'm closing this, and I hope the picture is clear to you that how to visualize your fixed data cube along a spectral axis. Okay, so I can review the code once again for you. So in part 1 we have like visualize only the data cube image at each z axis. So in my next tutorial I will visualize the data cube spectra at each XY spectral. Okay, so till we have like done for the 2D image. So let's review this code. So I have some library importing like feeds, pyplot, numpy and tqdm. So I have read this data cube from the MANGA website, and then I have extracted this flux data, and then I have plotted this image on a single z-axis cutout on a spectral axis, and then I have extracted all images on the spectral axis, and then I have saved this image as a PNG format in a folder named this, and after that I have used a glob library and ImageIO library to create animation out of this. So here I have read these PNG files, then I have read and stored in a list, and finally I have create a animation using meme shape. Okay, I have given the file name, the list of the images, and the duration of the each frame. Okay, so I hope you got the idea. So stay tuned for the next video in which I will be creating animation from this the spectra of the galaxy as at each XY spectral. So thank you.